Hi. So hello, everyone, and welcome back to our µTAS 2021 YouTube live series. I'm Dr. Anja Kunze, an assistant professor in electrical and computer engineering at Montana State University. And as we are now less than 2 weeks away from the full paper submission deadline here for the µTAS conference, I'm really excited to host today the seminar where we will have some tips and advice on how to put together a competitive µTAS paper, which is going to be presented by Professor Ryan Sokol from the Department of Mechanical Engineering at the University of Maryland, College Park. Well, yeah, let's work, or let's move forward from here. Ryan.
Great. All right. So thank you, Anya, very much for the introduction. So hello, everyone. My name is Ryan Sokol. And so today we're going to be talking about how to put together what we're referring to as a competitive µTAS paper. Okay. And so again, just to reiterate, for this particular conference, so a lot of times it could either be an abstract that's submitted or it could be a full paper up front. This time is indeed a full paper. Okay, so just keep that in mind, as that's why we're talking about this. So there's no, traditional abstract in the sense of the word. So let's keep going here. So this is the outline of what we're going to be discussing today. The reason I'm showing this here is basically if you are watching this in the future, so after this live session, what we're going to do is underneath the video, we're going to have a description, and we're going to update that with the time points so you can rapidly get to one of these parts as maybe you're putting together your paper like that final week or something like that. But for now, you're going to have to go live, and we're going to go through everything. So this is the breakdown we're going to talk about today. So first, I really did want to highlight just the concept of competitive conferences. And so this is something that maybe not everyone who's going to be submitting to µTAS this year might be familiar with. And so basically, there are some conferences that are a bit more of, anyone who submits gets accepted. That simply is not how µTAS works. And there's a number of conferences like that where it's a bit more competitive. This is a peer-reviewed conference. And so what that means is that historically you would either submit an abstract or a paper. And again, this time you are definitely submitting a paper, don't submit an abstract. And what happens is those papers are then handed off to a technical program committee who are going to go through every single one of these papers. And each member is going to kind of evaluate them. And then there's going to be some discussion. Sometimes it's in person, sometimes it's virtually, to kind of come to a conclusion as to which of these papers are going to make it into the final program to be accepted into the conference. Okay. And so to give you a sense of this, typically competitive conferences are usually defined by their acceptance rates and the integrity of the work that gets accepted. And so for µTAS specifically, historically at least, if we're looking at the oral presentation specifically, we're looking at in the range of about a 5 to 8%, acceptance rate. Now that's for oral presentations specifically. Now poster presentations is certainly much more forgiving. So you shouldn't be watching this and be like, oh, it's never going to happen for me, I'm not going to submit. You should definitely submit. But certainly certain parts of what I'm discussing today are really to try to give you a bit of an edge to get into that oral presentation category versus poster, if that's something that you're trying to do or trying to share your work a bit more with the community. So one question you might be wondering is why go through all the trouble to be able to attend one of these competitive conferences? And the answer from my view is quality. There is a massive quality difference, in my view, personally, between what you would see at a conference like µTAS and what you would see at one of those conferences that's a bit more of just, anyone who submits gets accepted and they're just happy to kind of take your money, so to speak. And so I would argue that some of I would say actually much of the work that I've been able to see in the past at µTAS, it has been great because what I've been able to do is basically I've been able to see work many years before it actually gets published in journal form. And all the key parts of the research is all there. It's all presented, it's all explained. Plus you get to talk to the authors as well. And you learn about it many years before it actually makes it out into like the public domain, so to speak. And so you can kind of get a little bit of a jump start in terms of new directions of research, or maybe you were working on something that you just ended up finding out, oh no, you've been scooped. And maybe it's not the right decision to keep going that direction because someone else is doing it, maybe even better. At least for me, it was a case like that where someone's just doing a better job. And I was like, oh, I'm not going to catch up. So to give you an example of this, in 2017, I had an undergraduate student, Josh, who presented his team's research at µTAS 2017 in Savannah, Georgia. And so this is from that particular presentation. And if you look up here, you're going to see that he was talking about this concept of fully 3D printed soft robots with microfluidic logic, right? And so let's say that you wanted to see this in journal form. You actually still cannot yet. So this paper was just accepted for publication about a week ago. And so if you look at the title at the bottom, you'll see this is like almost exactly what he presented basically almost 4 years ago at this point. Right. And so by attending that conference, you would have gotten a sense of, okay, this particular application is being developed. Maybe I could pivot my research to try to, coincide or synergize or capitalize on where this particular area is going, that kind of thing. So that's one of the major benefits to attending these kind of conferences and to participating. So let's move on to how to actually write a competitive µTAS paper. There are 10 parts to this. The first 7 are the ones we're going to focus on. The last are kind of just a little bit more easy. The first thing that you have to do is try to figure out what is the kind of the best title that you can come up with for something like this. So one of the examples that was included on the µTAS website, and we're going to link to these below as well, just for convenience. This was one of the titles that I thought was a really good title. As I mentioned here, you want to rapidly communicate the content as well as the novelty. And I think this, starting out with this embracing chaos, it kind of just, it hits in a different way than maybe other scientific papers might. Of course, you have to back this up with solid work, right? So you can't come off with like a really great title and then not follow up with great results and so forth, right? So it's a little bit of a balancing act, I would say. But really, it shouldn't be a balancing act. If you're submitting to µTAS, ideally you have really great work that you do want to submit and you want to share with the community. And so ideally, it's just really best to, in terms of the first impression of your paper, when people see that, it should be very representative of what you're actually presenting. But still, it is, I think, more helpful if it generates a little bit more interest and it's not too dry. And so the next part, and this is probably the most important part, right? So to kind of get back to the way that the technical program committee might be reviewing your particular paper, there's probably going to be over 1,000 papers that are submitted for this particular conference. That's kind of a standard for µTAS, right? And so that gets broken down, and each member of the TPC might be reading something between 50 to 150 of these papers, right? And so to be able to get their attention, to show them that, the work that you are doing, to try to make sure that they understand the novelty of it, exactly what you've accomplished and what is now possible because of that. It's really critical that your title and your abstract communicate as much of that as well as possible and as economically as possible. And so I'm starting here with the nature summary paragraph. So if you haven't seen this before, I think it is something that, is just a good thing for all researchers to have a sense of this particular format. You'll see on the left side, I have kind of a little bit of the details from this. You start with a basic introduction, you get into a little bit more of that more detailed background. You get into the general problem that is going to be addressed by your work. And then you have like that, here we show, here we present, here we introduce. You then follow that with your main results, maybe a couple sentences that provide more general context for those results. And finally, you come back to a broader perspective of the field. That's a lot. You do not have this many words for your abstract. You get 100 words. So take all of that and try to figure out what you would want most to be included in about 3 to 4 sentences as your abstract. And the rest could maybe be part of your introduction, or it could be part of your conclusions later on in your paper. So there's 3 examples I'm going to show you here. The first one is, again, it's from that paper that's on the µTAS website. That again, we're going to have a link to it here in the description. And so if you take a look at this particular abstract, you can break it down into basically 3 parts. First, we have the general problem that's being addressed by the work. Then we have, again, that here we show, here we present, or here we introduce part. And then we come into the main results. So that's kind of like the 3 parts there. For the paper that I had mentioned earlier with my student Josh, So we went straight into the here we present. So there was kind of like no background there. We just didn't really have room for it. And then we went straight to the main results, and that was it. And there was that was the way we had to handle it in that case, because there was a lot of information we wanted to convey related to those components. This is another paper from one of my students, Michael Restaino. This was a presentation, or this was published at µTAS 2019 in Switzerland. And so here we kind of flip the format a little bit. So we actually start with here we present, and then we kind of take a step back and we discuss the basic introduction to this area, and we discuss the general problem that's being addressed by our work. We then go into the main results, and then we have this tiny snippet at the end that's supposed to provide a bit of a broader perspective. So again, this is still 3 sentences, but it communicates all these different parts within that 100-word limit, right? So you have to keep to. All right, so another part to consider is that at the conference or after the conference, there's going to be basically this USB drive, and people are going to be able to use that to sort through all the papers that they might want to find. And so the keywords that you include help people to find your work, right? So, don't make it hard for Liam Neeson to be able to find your work. You want it to be as easy as possible, right? And so these are examples from, again, one of those papers that was provided as an example. And this is for my work. And so, some people use the term 3D printing, other people use additive manufacturing. And so I just want to make sure that, whatever they're looking for, they're going to be able to find it so that they can learn about our work. So now we're going to get into a little bit more of the meat of the actual text, right? And so the introduction is a tough one, because basically in a very short amount of space, you want to try to provide as much of an introduction as you can. I would recommend about 4 to 5 sentences. So one is one sentence that justifies, why is this work important in your field? A second sentence that, in some cases, these can be combined into like a singular sentence with like multiple parts, but then we're going to get into the prior work, right? So you really should be highlighting, what are the major key works, the seminal works in your field that kind of your work might be building off of, or just it should be compared to, that kind of thing. And then what are the critical barriers, right? So what is a problem? And it kind of relates again to, what is the general problem in this field that you're hoping to solve, or you would want to solve, or maybe you're just taking a step to be able to solve it. And then some type of guidance, right? So explaining, what would be needed to be able to address those critical barriers, right? And so hopefully in those, 4 to 5 or 6 sentences, you're able to get all of this information out clearly. Anything else that's superfluous to this, you just don't have enough room. 2 pages for an entire paper is just, it's not enough. So this has to be very succinct and tightly written to be able to communicate as much as you want to, or you should, in a pretty small amount of space, in my view. So now we're going to get into the experimental section. And the purpose of this is basically you're trying to help explain to anyone who reads your paper essentially the key details that they would need to know to be able to walk into lab today and try to reproduce your work, right? And so that they could actually begin implementing whatever it is that you've described or explained and begin to use it in their lab. So what are the key things that they would need to know that? So certainly the concept is a big one. So explaining exactly what is your novel concept. Next is going to be fabrication. So what are the key fabrication details? A lot of times this can be easy. If you're using soft lithography, you can just cite, a soft lithography paper. If you've already presented the basis of the fabrication process, you can cite your prior work here. That could be helpful. Another part is the experimental setup. So how are you performing these experiments? And this could also be like theoretical, right? If you have theoretical models, that could also be included in a section. And then how are you recording your data and analyzing your data? So those are kind of the 4 main parts that you would want covered in this experimental section. And you'll note that I included, and figure 1 in the title here. Figure 1 is a really important opportunity, okay? And so when you are explaining your concept, right? So when someone looks at your paper, it's likely that their eyes are going to go straight to the title, maybe the abstract, but then probably also figure 1 to get a sense of what your work looks like. And so you want to be, I would say you want to focus significantly on making your figure 1 as strong as possible to communicate that information quickly. So when you are putting together your figures, you're probably only going to get roughly 3 figures. There's only so much room in these 2 pages to include too many. So again, I'm including it here as economically as possible. You want to communicate that information rather than in text, but you should really be including it ideally in figure form. And so basically the more information that you can communicate through a figure visually, especially for people, right? Not everyone is a native English speaker. And so being able to communicate that information in a way that's very easy to visualize can really help to make sure that people really understand the contributions of your work. So I'm including a couple examples here. Again, you're going to have lots of examples or some more examples on the µTAS website. So this is one from that student Josh's work where he's including, hey, here's a capacitor up top. This is how it operates. And here's what it looks like for real in real life. We took a photo. Then the next one is a diode. Hey, fluid moves one way. It doesn't go the opposite way. And here's another picture. And then lastly, here's a microfluidic transistor. It's open, there's flow. And then, hey, look, if you add this gate pressure on the bottom, then it closes and there's no flow, right? So just trying to get, it's a lot of content that we're trying to get through, in a very small amount of place. And then here's another one from one of my students. And so basically in this case, you have a microchannel, you're putting some photoresist that has some type of material inside this reduced graphene oxide. And then in the B panel, we're showing how it gets fabricated. So ideally from this figure one, you can kind of grasp like all of the key concepts from this particular work. So this is a little bit cheating because it's not exactly this conference. This is IEEE MEMS, but it's also considered a competitive conference. And I would say it's analogous in certain ways. But again, more just to provide you with some additional examples of these figure ones. So this was one trying to show this multi-material printing process and how you load these different materials in a fluidic chamber, and then you can expose them to make your particular designs. And then this is one that we recently published. Again, where basically we're 3D printing these microfluidic structures on top of these fused silica tubes. And basically at the end, it has to be something where fluid can move through it. So we're trying to show as much of this as possible without you even having to read the caption underneath it, right? So that's kind of the goal of what we're targeting here. So then there's kind of the meat of the paper, which is the results and discussion. And this is something that really you should focus on significantly because, if your concept looks beautiful, that's great. But if you don't have the results to back it up, if you cannot prove that you built the devices that you said you built, if the results are, not what they're supposed to be, or, it's possible you might justify that or something like that. But really, everything needs to kind of come together in the results and discussion section. And so there are a couple of things you want to focus on. In the text, highlight very specifically the key results of your work. And in particular, if there's anything that you weren't expecting or anything that a potential reviewer might not be expecting, that is the kind of thing that you want to describe here and say, we weren't. And a potential basis for this result is blank, that we didn't think we were going to see, but we did. That kind of thing. Figures, it's the same context, right? So you want to have it so that nearly anyone can understand what it is that you're presenting in your figures without having to dive deep into the text or into the captions. But you have to make sure that you're being truthful and accurate in your presentation of data, right? So there can't be anything that's misleading. Those are kind of things that if there is something that's misleading, that really is just a terrible thing. And there's no reason to be doing that in a scientific field. It's just not something that really should be done here. So just make sure that when you present your data, you're not trying to misrepresent it. You're not like taking out data that you just don't want to talk about. Just be truthful, because sometimes you might end up discovering something that you didn't even expect because you included that bad data, but it ends up actually being good because there's a new phenomenon you discovered, that kind of thing. And then the last part I would say is be very meticulous in terms of how you put these together. It should be very readable. And maybe not for this particular conference, but for other conferences, oftentimes the TPC will have printouts of every one of these abstracts or papers. And so you want to make sure that when it's printed, that all of your lines, everything looks clear and everything is very readable, right? If you make it very challenging for people to read, that kind of undoes the whole point of sharing your information, right? You want it to be as clear and easy to understand as possible. So this is an example of a fabrication process from one of my students' works from Michael Rosano. And so in this A panel on top, we have computer-aided manufacturing simulations of what the fabrication process should look like. So because a lot of people would see a spiral and assume that we're just going like this, but in actuality, we're actually doing a point-by-point, layer-by-layer process. And then in B, we have what it actually looks like in real life and how much time that takes. In C and D, we have fluorescence micrograph and then also false colored SEM to just show what it looks like afterwards, right? So this is kind of everything that one would need to see and it doesn't take up that much space, which is one of the reasons that we like this particular format. So try to see what that would be for you. This is an example from one of the samples that was provided, again, on the µTAS website and is linked to you below. I thought there was a lot of information that needed to be included in this. And I think that the authors did a really good job of communicating as much as possible in a way that's professional and readable and so forth. And so try to take all of these just as examples to better calibrate yourself for some of the standards in these fields. And if you're still not sure, I would recommend just reading some of those top tier papers that end up, from our field that end up in Science or Nature or Science Sisters or Nature Sisters, to try to get a sense of what is the formatting that it should look like that you can mimic. So conclusions, we're almost done. So the big one here is just the conclusions is not a summary. You should not be just like copying and pasting your abstract for a second time. If you can, try to provide a little bit of a higher level, I'm saying a higher level of analysis to these results. Also try to provide guidance. What do you recommend that future researchers should investigate in this particular area? And then lastly, I think try to bring it back. So because of the work that you've presented, what is the potential impact in terms of your field? So what can researchers now do? Are there new applications? What could that be based on your work? This is a great area to kind of really highlight those capabilities based on what you've done. So then, of course, there's the acknowledgement section. Make sure that you obviously thank your funding sources, and then I'm saying acknowledge anyone who substantively contributed to the work, right? So you don't have to thank every single person, someone lent you an eraser or something like that. That's not someone who makes it, right? But people who really did participate, but not enough to be a co-author, they belong in this particular section. So references, there's really two formats that you could consider. So there are references that are kind of this long format, and there's also this more short format. You can choose based on how much space you have, kind of which, but you want to make sure that anyone who wants to find these papers will be able to. And then lastly, you need to include contact information. And so there's usually like a corresponding author with like a journal paper or something like that. But for this, it won't be that kind of case. And so you probably are going to want to have just the first author can have their information, but don't put your cell phone number, put your lab's phone number, your professional phone number. This is where that would go. And so that is it. So, and obviously good luck in terms of putting this together. Again, June 8th is the deadline for these full papers. So keep your eye on the target there. So.
Thank you so much, Ryan Sokol, for sharing your really thoughtful insights here, how to derive a competitive conference paper, not only for µTAS, but I think with the approaching deadline, this is really where you can apply all those knowledge immediately. We are taking today questions, so please use the chat over there if you have specific questions for Ryan or for me to get deeper into certain things regarding the paper. And then furthermore, I do have a question for you regarding the specific 6-month grace period, which is probably special this year.
Yes, so for this particular circumstance based on everything that happened with COVID, there is a bit of a different grace period where anything that has been published in the last 6 months, you can basically kind of like resubmit that to share that with the community as a paper. So obviously, we definitely want to see novel work as well, but it would also be great, if there are things that came out that just with COVID times, just people weren't able to see it, or maybe might have missed it just because of everything that was going on. There is this opportunity to be able to share it again. So I think I forget exactly the date, if it's December 8th. So anything since then that you published, even in journal form, you have an opportunity to resubmit that actually as a paper for µTAS. And so consider that as a kind of a unique opportunity for this particular year that I hope never happens again in our future.
Great, thank you so much. Yeah, I hope this is very helpful here to get a better idea what can be included this year and what you should maybe save for next year as well. Okay, so I think we're coming to an end over here, and I don't see particular questions in the chat right now. So let's tune in next week when we will be discussing µTAS awards and upcoming events for attendees at the conference, specifically in person or remote as well. And there I would like to thank Ryan Sokol again for sharing his insights here. And I wish you a wonderful day. Thank you. Bye.
Okay, we're good.